session is called Formulas 1. I would strongly recommend you, before you do this, review the session called Pre-Formulas. So let's start. Let's take a look at this little bit of a periodic chart, periods 2 and periods 3, and notice all the elements in period 2 are omitted except neon. The yellow dots, 8 of them, represent what's called the valence electrons. The valence electrons. These are the electrons of chemistry. These are the electrons that another atom sees when it approaches it. Now, it's not literally seen. It's what it comes in contact with. The inner electrons, the core, are the ones another atom does not see. Neon has 10 electrons, 8 valence, called the octet, to the core. Octets, we found, were very stable, whether they're in an atom or whether an atom gains or loses electrons to become an ion. When they achieve what appears to be to another atom an octet, they don't react. For instance, sodium. Notice it has 1 valence electron. It's atomic number 11. If it loses that 1 electron, it's very easy to look like neon. Sodium then loses a negative. It becomes Na, a 1 plus ion, a charged particle, ION. Magnesium would tend to lose 2 electrons. Now, if it gained 6, it would look like argon. That's stable also, but it takes the simplest route. Magnesium becomes 2 plus. Aluminum, losing 3 electrons, becomes 3 plus. Silicon does not form ions, so we're going to skip it. Phosphorus now has 5. It's easier to gain 3 than to lose 5. Sulfur gains 2. Chlorine gains 1. And of course, whoops, it's minus. And argon is a noble gas. So you have 1, 2, 3, 3, 2, 1. These ions are called, the positive ions right here are called cations. Good vocabulary word. Cations, attracted to a cathode. These ions over here are called anions. Negative ions, single negative ions, anions. All right. Now we're going to make some compounds. These things are formed either naturally in minerals like sodium chloride, for instance, and we'll just list a couple of these right here. Here's sodium. We'll list it 3 times. It's a 1 plus. And we're listing it 3 times because we're going to combine it with these anions. Cl1 minus, S2 minus, and P3 minus. All these negative ions, all these anions, end in the ending IDE when you name them. The metals, you just name them. So this becomes a formula, sodium chloride. The plus 1 and the minus 1 adds up to 0. NaCl. Sodium chloride is a mineral, halite. It comes in a lot of different colors. Brown, bluish color, gray color, pink. I got some sodium chloride from Salzburg, Austria, when I was in a salt mine there. And it is a brownish color. It has iron ions, impurities in it. So these are minerals, but some of them are man-made chemicals and they are pure substances. Sodium sulfide, Na is 1 plus. You must have 2 sodiums for every sulfur ion to add up to 0. So we use subscripts. It's a number below the element. Not above it, not in front of it. Sodium sulfide. Notice you don't even say anything about the 2. It's just part of the balancing. And this becomes sodium phosphide. You can do the same thing with the next one. Calcium. And we'll put the anions down here. Chloride, sulfide, and phosphide. Put them together, 1 calcium and 2 chlorine becomes CaCl2. Has to add up to 0. Next one is just CaS. Next one's a little tricky. You have to have 3 of these, 3 calcium, for every 2 phosphide. Very poisonous calcium phosphide. You can do the same thing with aluminum. Al3 plus Al. And we'll put down chloride, sulfide, and phosphide. And this time I won't rewrite them. I'll just well, I will. AlCl3, Al2S3, and Alp. Now, these anions can also be more than one atom combined. They're called polyatomics. And I have a chart up here on polyatomics. Polyatomics, get to know them. Get to know them. It's like if you meet 30 students in your classroom, you get to know the people, and then you'll know the names. If you just try to memorize them right away, you can't. So work on these. I strongly recommend you memorize them. So let's start with a couple quick ones here. Look back here. Here we'll take sodium 3 times. And we're going to add nitrate. This is 4 atoms combined with a charge, nitrate. And we'll take sulfate, 2 minus, and phosphate, 3 minus. Formulas are Na, NO3. And now this is 2 sodium ions for every sulfate. The sulfates all combined in 1 unit, and this would be Na3, PO4. If you have more than one, with a cation calcium, and you have nitrate 1 minus, you have to have a parenthesis here, otherwise it looks like Na32. Calcium sulfate, you don't need a parenthesis, just 1. But if it's phosphate, you need a parenthesis for 2 of them. Okay? So the facts about all these substances you see here, the facts. If you look up here, they're all white solids. They have a high melting point you could check out. They're crystal. So we say they're white, almost always. Crystal. They're brittle. Smash them, they break, not like metals bend. They are solids, of course. Most of them are soluble in water. They'll dissolve in water. So you would learn to memorize or discover these things by observing them. I would go on now to formulas number 2 session, and we will stop right there.